Welcome to Math 106, Chapter 2.2, where we talk about the first and second derivative rules. So the previous lecture, we were talking all about what we see in terms of graphically, and now we're starting to see, okay, well, given some material, given some information, can we start to perform and make an idea of what this graph looks like? Given that we have our knowledge of the first and second derivatives, now that we know how to take the first and second derivatives. So it says, suppose that for some values of x, say x is equal to a, the derivative of your first function, of your first derivative of a, is positive. So how to say it's positive is the first derivative of f at a is greater than 0. So that's how you're kind of interpreting it, right? It's greater than 0, it's positive, greater than 0, therefore it's positive. So if that is true, then the tangent line at that particular point A, now it's at a full point of your original graph, has a positive slope and therefore is rising. So if the slope, kind of as we've done in the previous one, notice how we were drawing those kind of black lines, right? If it's positive, if it's a positive slope, our graph is therefore rising. Now, since f of x near that particular point resembles its tangent line, the function must be increasing at a. So for example, if we were to make a quick picture, so given some sort of a function, if we know that your slope, right, is positive and it's increasing. So if we were to draw a series of tangent lines where your graph is rising, right, your tangent line is positive, it's the first derivative is positive, your tangent lines are positive, and it's therefore going to be rising. So to kind of connect this idea, this, oh, and I don't like how I did that. Let's see, trying to notice how it's kind of flowing with that. This is f of x. This is rising. Given that we have some sort of coordinate a and f of a. So your graph at these particular tangent points, if it's greater than 0, so if your slope at this tangent line, if the slope is greater than 0, therefore it is rising. Your function is increasing. And we could do the reverse as well. If your first derivative is positive and f of x is increasing, right? Or if your first derivative is less than 0, therefore it's negative. Right? Negative. Then the tangent line is decreasing. So if we were to draw a quick picture, make now negative slopes. And draw the same kind of graph. Notice that all the slopes are negative. We are decreasing. So this is f of x. And again, this is a, f of a at a particular point, a f of a. And if we were to highlight at that particular graph, your slope is less than 0. What we're referring to is that this being your first derivative, this is your your slope of your tangent line. That is what is going to make it positive or negative. So it says, again, with detail, a function is increasing when its derivative is positive, decreasing when its derivative is negative. It says nothing about what happens when the function is 0. It could be increasing, decreasing, or some sort of, as a result, extrema, or neither. So what we're going to be seeing is that we're going to be mapping with example 1. This idea is your tangent line, right? The first derivative is all about your tangent line. It's going to tell us, are we increasing or decreasing? So first, in example 1, it says sketch the graph with the following properties, A and B. So first, A is just saying what? It says, well, f of 3 is equal to 4. This is giving us a particular point, 3, 4. Let's go ahead and put that on your graph right here. 1, 2, 3, 1, 2, 3, 4. So this is our point here. Maybe I make that just a little thicker. This is your point, 3, 4. Then it says your first derivative is greater than 0. First derivative is greater than 0 is positive. For when x is less than 3. And we said if it's positive, if your first derivative is positive, we are going to be increasing. Your graph, your original graph, that in blue is going to be increasing. It then goes on to say your first derivative at when x is equal to 3. When x is equal to 3, it's equal to 0. This is referring to the slope of the tangent line. And I'm going to put that in a different color. You'll see that here in a second. Slope is equal to 0. So m is equal to 0 at this particular point. And we know that this is your first derivative. Which gives us information about the slope of the tangent line. So if we know that the slope is 0 at that value, well, what kind of lines are at 0? That would be horizontal lines. So we have a horizontal line here when x is equal to, or when x is equal to 3, right? X is equal to 3 is right here. Maybe I'll label that 3, 4. So this is when m is equal to 0. And we said, okay, well, we're going to be positive. We're going to be increasing. For the x values that are less than 3. And then on the other side, your first derivative is less than 0. So therefore, it's negative. So your slope of your tangent line is negative for the values when x is greater than 3. So on the other side of 3. So notice that 3 is kind of up for grabs. You have 3 here, and it said when x is less than 3. So what values are less than 3? Well, that would be 2, 1, 0, -1, -2, -3, right? We are going to be increasing. We're going to be rising. So your slope here will rise all the way until it gets to 3. So all of these little tangent lines that I can make, they're all increasing until I get to 3, where it's now a critical point and it flattens out. And then when x is greater than 3, so what numbers are greater than 3? 4, 5, 6, 7, 8, 9, 10. So on the right-hand side, our first derivative, your slope, is now less than 0. It's a negative slope. So we're going to be trending down. So we're going to go down versus on the other side, we went up versus in the middle. So now we're going to be trending downwards. And I like to use arrows to suggest that we've gone a certain direction. And notice that you can see if we made a series of little tangent lines, that those are now all negative. Tangent line negative versus tangent line positive. And this is how you can graph based on the information given. Now, the most important ideas here, I'm going to see if I can find kind of a good color, is that the first derivative, and I want to do maybe something big, key. Your first derivative tells us about the slope of the tangent line. If it's positive, we're increasing. If it's negative, we're decreasing. Here, I'll redo it. If it's positive, we're increasing. If it's negative, we're decreasing. And if it's at 0, we're nice and flat. That's the first thing. Critical points are equal to extrema, a max or a min. This is when the slope of the tangent line is equal to 0. That would be right here. We have a critical point So your critical point is where your slope of your tangent line is equal to 0. And that is going to be a key feature when it comes to graphing these things based on some derivative information. So based on your 2.3 coming next. So now that's all about your first derivative. So first derivative tells us about the slope of the tangent line. Your second derivative gives us different information. Second derivative is useful about your concavity. So suppose that the second derivative, when x is equal to a, so at a particular point, when x is equal to a, if it's negative, so if your second derivative is negative, right, to see that, second derivative when x is equal to 0, or when x is equal to a, when it's less than 0, this is suggesting that it's negative. So since the second derivative of your first derivative, we can conclude that your first derivative has a negative derivative. At that particular point, bear with me. In this case, your first derivative must be decreasing, because if your first derivative is negative, it's decreasing, right? We saw that over here. First derivative is negative, therefore we are decreasing. We're going down. So we are a decreasing function. So now it falls in line with your original graph decreasing. That is the slope of the graph. So now your original graph is also decreasing. Therefore, your concavity should be downward facing at that particular point. So to kind of picture that, we're going to talk all about it. So if it's not making sense yet, don't worry, it's going to click eventually. So if your first derivative is decreasing, right, it's going down. Right, so if your first derivative is down, therefore your graph also is falling. It says that therefore your second derivative is concave down. You can see that here. And again, at a particular point, a, f of a, here. So the second derivative just says, if the second derivative is positive, it's concave up. If your second derivative is negative, it's concave down. So the positive, up, negative, down. Positive, up, negative, down. So now let's say we have some of these. It says nothing about so far when your second derivative is 0. It can be up, down, or big neither. So let's take a look at these series as a condition of your derivatives. It says if a is positive, so your first derivative is positive. That means your tangent line is positive. Therefore, your second derivative is positive. So we said positive second derivative means it's concave up. Therefore, we are an increasing function with concave up. Can you go ahead and try to draw that? An increasing function concave up. That would look something like this, where we are concave up throughout its duration, and your slope is also increasing. It's just positive, sorry. Now let's do it again. It says your first derivative is positive. So are we going to be an increasing or decreasing function? Well, if your first derivative is positive, it is going to be increasing. There, and your next, it says if your second derivative is negative, which we said second derivative being negative, it's got to be concave down. Therefore, if we were to see this picture, right, your first derivative is positive. All those are positive. However, these are all downward facing. This is what your graph would come out with. So now let's see if we can make that same idea with 3 and 4, filling kind of in those gaps here based on this picture. So it says your function is decreasing, and we can see that here. Your function is decreasing. Now, what does that say about your first derivative? Well, these slopes, therefore, are all negative. So we are positive, or we are negative. Your first derivative, therefore, has to be negative. We're also concave up. Now, what does that say about your second derivative? Well, your second derivative, therefore, has to be positive. And if we were to do it again, based on this picture, drawing those little tangent lines, these are all negative. Therefore, if it's negative, our function is going to decrease. And we can see that decreasing function here. Now, what about your concavity? Well, your concavity is all downward facing. Therefore, we are concave down, meaning that your second derivative is negative. So notice that you can have all sorts. You can have positive, positive, negative, negative, positive, negative, or negative, positive. And these are all of the series of your graphs that you can have. But keep in mind, again, the emphasis on the key here. Is that your first derivative is the slope of the tangent line. The second derivative is the concavity. We can either have positive or negative. Positive, negative, or neither. which neither suggests it's a critical value. Concavity, we can be up or we can be down. So we can be positive or we can be negative. Now, again, we haven't talked so much about your second derivative when it's equal to 0. That provides us with information. Just like your first derivative when it's equal to 0, this provides us with a critical value, which maybe I emphasize that just a little bit more here. Okay. So now let's see if we can sketch example 2. So part A is the easiest. It says 2, 3, 5, 4, and 6, 7 are all on your graph. So let's go ahead and put those on. And if you can, see if you can pause the video here and see what you can do to start. So at 2, 3, we have points. For, let's see, 3, 4, 5 right here. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7 right here. So these are my points here. And so that takes care of this bit. So that's A. Now it says the first derivative of 6 is equal to 0. Now the first derivative provides us with what type of information? Well, that provides us with the slope of the tangent line at when x is equal to 6. This is equal to 0. So your slope here is equal to 0. So at 6, let's see, 1, 2, 3, 4, 5, 6, we have a slope equal to 0. And again, another one when x is equal to 2. So one more when x is equal to 2 here. And I might just have to label my x values. We have 2, 4, and we have 6. We have 3, 5, and 7. So when your slope of your tangent line is equal to 0, what are these points actually called? Well, these are called your critical points. These are your extrema. This is either your max or your min. Now let's go ahead and read your second one now that that first part or the second part is out of the way. Now it says your second derivative, which talks about your concavity, your second derivative is positive, right? So if it's positive, therefore it's got to be concave up. So if it's concave up for when x, and it looks like I made a mistake on my notes here. Let's go ahead and reverse this. This should really say this part. So how do I read this? Well, this is when x is less than 4. So what values are less than 4? Well, that would be 3, 2, 1, 0, -1. So it looks like on the right or on the left-hand side, we're going to be concave up. So if I were to draw a little miniature one, so when x is equal to 4, we're going to be concave up. So drawing little ones. And so far it doesn't tell us to stop. So everywhere where it says it's greater than 4, we're just going to have this concave up sort of look. Then when it says your second derivative of 4 is equal to 0. Now we don't know what that is, so we're going to pause and continue. We'll come back to that. So now here it says your second derivative is negative, meaning that we are now, if it's negative, it's got to be concave down for when x is greater than 4. So that would be 5, 6, 7, 8, 9. So on the right-hand side of 4, it's got to be greater than 4. So concave down. So all of the ones on the other side of 4 got to be shaped like this. And notice that by doing those little teeny tiny movements, right, those little tiny ups and downs, we can go ahead and shape your graph. We don't need this information here quite yet, right? But let's go ahead and bring this into shape. So your shape of your graph should look something along the lines of this. Now, it doesn't suggest what happens after, but let's say it's assumed that it's continuous. Notice that the little concavity kind of tells us if we're going to be concave down or up. Now that we have everything put in place, what do we know about this point here? Well, this is called your inflection point, right? Because your inflection point is the change in your concavity. One more time, if I can get it. One more time. Let's see. Oh, well. This is your inflection point. Inflection point is where we have a change in concavity. So that just means your tangent line here must cross your graph at some point. So your tangent line will cross. Everywhere else, it doesn't. Right here, it should be decreasing. Then it starts to increase. And then it switches. And there you go. So your inflection point, so again, another key. Your inflection point, your second derivative of A, when it's equal to 0, is an inflection point, where the concavity changes direction. And that's it. So just be aware. I know it looks kind of like a mess, but there's like so many things. First off, start to plot, then start to think about, okay, if it's equal to 0, if it's a critical point, put those on, and you can see those ones are very easy to get. Then when it comes to the others, leave your inflection point for the end if you don't know what it is, but start by breaking down when x is less than 4. So if we have your inflection, if I were to draw a little point here, and there's 4 in the middle, on the left-hand side, we're going to be positive. This would be at 3, at 2, and so forth. We're going to be concave up, whereas 5, 6, and more, we're going to be concave down. And at itself, at 0, we now go from up to down. So we're neither right here. If you need some more practice, the next example after the following video should have a little bit more strategies with this, and we'll just graph a few more from your textbook.